Welcome there, function folks. Lesson 3.11a, compound trig identities. And we got another one of these days where we're sort of back and forth between a video and an activity sort of thing. So this video takes up the 3-minute review and sets up the investigation that we're going to do. Either you do at home by yourself and take it up, or in class, and I'll let you plan that. And there's the plan. There's this video, and then the investigation, and then there'll be a video that tells us some homework examples. And today's kind of a big day as far as learning is concerned, a little bit of a smaller day tomorrow. You might be wondering, what's the deal with these investigations? Last day we had an investigation. Really all we needed to do is come up with some formulas. And that's the same thing today. The investigation will be you filling out this sheet and coming up with, at the end, you come up with, geez, a bunch more formulas. So, why? Why don't we just write down the formulas and then start memorizing them? Maybe it'll be faster that way. Well, the philosophy is that if you do the development of the formula yourself, you make the connections yourself. It's the same as when you read stuff in the textbook. You make the connections yourself, you're more likely to remember the formulas. And that's the whole idea, is for you to make the connections and not me just give them to you. So that's what we're going to do. We're going to struggle with the development of the formula a little bit, and then we'll see how these silly homework questions help us remember them as well. Like this is a silly homework question. This match them up, and we can see, well, look, those are equal. No. We want to use the formulas from last class and see if we can come up with a connection. One way would be, I know what the sine of pi over 3 is because I know what my special angle chart is, and then I can just look up which one of these ones is the same. Well, yeah, I know you could do that, and if it was a test question, certainly that would be one way to solve this question. But here we're just trying to remember. The formulas we learned yesterday. So, for instance, this one. Hopefully, this is looking a little bit familiar. It kind of looks like this one, right? That's that odd function formula, right? Sine is odd. And so here theta is just pi over 3, and these two are connected. Next, let's go on to the next one. And again, I know that you could just use your special angles or triangles or whatever and figure out what the value of this is, but we want to just get practice with our cofunction identities. So what are the two cofunction identities? Well, we've got this one. And we've got this one that have sine involved, right? And we have to decide which one we're going to use. Now, do you remember the right-hand sides of these? Well, the right-hand sides of both of these are just cos theta. And in fact, that's how I remember the cofunction identities, is it's the other trig ratio, primary trig. So if it's sine, it's cos, and just with the angle, the acute angle theta usually. And so in this case, all I have to do is I have to decide this angle here, has it been is it less than pi over 2 and I've had an acute angle subtracted from it, or added? Well, pi over 3 is in the first quadrant, and so it's got to be this formula. So all I need to do is figure out what theta is. And some of you might know this exactly from the trig graphs, right? We got 1, 2, 3, there's pi over 2, and there's sine. Well, what have we got? This is pi over 6 and pi over 3, so if there's 3 ticks, 2 of them are pi over 3, one more tick to get to pi over 2. The little theta must be pi over 6, but I'm going to go through the little calculation that we showed yesterday just to practice this. And this is subtract theta equals pi over 3. So again, if we're going to use this formula, this thing has to be equal to my angle pi over 3. And how do I solve this? I'm going to isolate theta. Theta goes on the other side, rather. Having trouble with the pen here this morning. Pi over 2 minus pi over 3, right? Bring this over to this side as well. And common denominator is 6 multiplied by 3 on the top and bottom, multiplied by 2 on the top and bottom. Indeed, there is my 3 pi subtract 2 pi is pi over 6, and that's theta. So therefore, theta is pi over 6, so this must be the cos of pi over 6, and these are the ones connected. Dandy. So that means by default, this one must be the answer, but let's practice, okay? Again, the other cofunction identities from last time are these two for cosine. And again, it's the other one, right? Now, the only one that's different is the cos plus is the one with the subtract on it, the cos plus. And how are you going to remember that it's only this one that's different, right? It's always, if it's cos, it's sine, if it's cos, it's sine, but except for the cos plus one is got a negative on it. And you could just memorize that, or one way to think of it is, remember, when we add a little bit from pi over 2, the cosine goes into the second quadrant, right? There's pi over 2, but if we have this theta in the second quadrant, the x-coordinate, which goes with the cosine, the x-coordinate's negative, okay? And that's another way to remember that that's the only one that's negative. And notice, here, my 2 pi over 3 is more than pi over 2, so it's this formula. I'm going to use a different color just to spice things up. It's this formula we're going to use. So again, I want to find out, same little calculation, when is this equal to this? And I'm going to put that on the other side. Theta is positive on this side. 2 pi over 3. Common denominator, bada bing, bada boom. Here we go, that's pi over 6. And so theta is pi over 6, so that means this must be the sine of pi over 6, and it's all good. Dandy. Right, so what are we up to today? Or now, depending on how you want to time manage yourself and with your group members, is this is the compound angle investigation, and it's using some of the formulas from yesterday, as promised. Notice this first one, it asks you to do sine of negative theta. Well, that looks like that odd one, right? It's this one, except for if we only need this part, right? That's all we need is that part right there. What do I do with the minus? I divide both sides by -1. And so then I get this other formula. And that's another version of the odd function formula. And this is the even function. Cos is an even function. This one, do you remember what the rule is? Well, it's the opposite, or the other primary trig ratio, sine cos, and it's not cos plus, so there's no negative. It's not cos plus, so it's no negative. This is just sine theta. And these ones are going to be used to fill in these blanks. Now, how does this work? It all goes with this diagram, okay? And this diagram says that this length, CD, is 1. And then I can just go through, follow the instructions, and fill out the sheet. So sine of A plus B, for instance. The sine of A plus B, well, there's the angle A plus B. The sine is opposite, a nice straight line there, opposite over hypotenuse, right? So the sine of A plus B is opposite ED over hypotenuse CD, but CD is just 1. So then sine of A plus B is just ED. Or it says ED is the same as HF. But notice HF has got, because this is a rectangle, right? You see the rectangle? Long thin rectangle. HG plus GF. And essentially what this sheet is doing is walking you through the development of the formulas. The next thing is to do some angles. So let me go back and just erase this. And then I'm going to stop talking and let you try the investigation on your own. This angle 1 here, look at this triangle here. Well, the 3 angles have to add up to 180, well, what we would think of in degrees, but pi, right? And so if this is pi over 2 here, then these 2 angles have to add up to pi over 2. And so what's angle 1? That's just pi over 2 minus A, right? because these two have to add up to pi over 2 because pi over 2 is there. The three of them add up to pi altogether. So this one's pi over 2 minus a. And then you can walk through and find expressions for the other angles. And we'll see that at some point this angle 4 is the one that you really want. Okay? That's the one that we really want. And then eventually you're going to get expressions for each of these little pieces in the diagram. So for instance, if I look in this diagram, CG is right here. It says I want to fill in expressions for each of the line segments in terms of sine A, cos A, sine B, cos B. Well, if I look in this triangle here, and I'm thinking about this triangle here again, because this hypotenuse is 1, right? And then the side CG is the cos of B. Watch. Cos of angle B is adjacent CG over hypotenuse CD. But CD is 1, right? And so what's CG? CG is just the cos of B. Okay, and then you walk through and you get expressions that have, some of these will be, these ones here, by the way, hint, or be a little more complicated, and this will allow you to develop expressions for the sine of A plus B and the cos of A plus B. And, geez, wouldn't it be nice if it was just sine A plus sine B? Wouldn't that be wicked awesome? But guess what? It's just not that case. It's actually a lot more complicated than that. So you go ahead and you walk through the sheet, and then by the end you'll actually have 6, count them, 6 new formulas to remember. But we'll talk about when we take it up. Easy ways to remember, patterns that occur, ways to develop it. Do I actually have to memorize 6 formulas? And that will all be, this will all be covered and more in part 2.